Today we're going to be looking at scatter plots as we look at our two pieces of data. Making a scatter plot, you need to be able to do that. Today the other thing is when we look at our scatter plots, we're going to look at, are they clustered? Are there any outliers, a point that's way off from the norm? Like when we look down here, these 2 points kind of seem like outliers if we are looking at those. They're way out away from everything else. We're going to be looking at a positive correlation and negative. Positive correlation, remember, that's when you go up to the right, kind of like our slope. Negative correlation, going down to the right. Linear, being a straight line, could be going up, could be going down. Non-linear, meaning it curves, kind of like the one down below. But it could also be one like where we are looking at a correlation this way, where it goes up or down, something along this line. This one down here is a definite non-linear. This one is all clustered, kind of hard to tell what type of if it's linear or non-linear. And it says I can describe the pattern in terms of the situation. So these are the things we're going to be looking at in today's lesson. Again, a scatter plot is a graph of a bivariate, but it's numerical data. So the last couple days we have been really focused on our data that was categorical. When we look at it, it's going to be an ordered pair. Remember, our ordered pair is our x, y coordinate. And usually it's always in the first quadrant. So you'll notice all of these here, we're kind of plotting them in the first quadrant. It says you can use a scatter plot to find trends. Scatter plots below show 3 different types of relationships. This first one is a positive relationship, and if you think about slopes of a line, this is where we had our positive slope. So as x increases, the y increases. So I like to think of this as x is increasing, the y is increasing. In a negative correlation, again, as we look at our negative correlation, it's kind of like our negative slope, okay, if we could draw a line. And this is when x increases, the y value decreases. So as x is going up from 1 to 2 to 3, the y value is going down. The last one, there's no correlation between the two. There's no relationship, and if we think about this one, we kind of talked about this the other day in class, your shoe size and your grades, or your shoe size and looking at your, something else we could take a look at as numeric data, but there's no relationship between. Positive and negative, then we also talk about if it has a strong correlation. Are the points kind of close together? Like these would be both very strong. Or are they more scattered? Then it's going to be weak. So you're asked to look, and the next bottom part of your notes here is, as we look at these, what kind of a relationship do we have? So on the top of the next page, you're looking at this in your notes. And as you look at this, we would say this first one, it kind of looks like, if we were looking at it, the type would be negative. And if we are talking about the strength, we would say the strength for this one is pretty strong. It looks like it's negative going down, almost like we could draw a straight line going something like this. And usually you want to probably have your line in the middle of your data, so that first line of mine wasn't the best, but it's a little harder writing on the tablet. The strength would probably be strong for this one. Here, if we are looking at this, it kind of looks like it's positive, like it's starting to go up, but it's not very strong, so we're going to call this one positive, and it would be weak if you're thinking about it. Take a look at the bottom too. Think about shoe size and your IQ. Really, no relationship, right? No correlation. And if there's no correlation, we can't really say if it's strong or weak, but in this case, because it's real spread out, we'll call it weak. This next one, if we look at this, it's kind of going down again, if we're looking at our data points. So we would say this is negative, but in this case, it's probably a pretty weak negative because it's not all clustered together. This one was much more clustered together. Now, you are also going to be asked to make a bivariate data to actually make a scatter plot. And what I want you to think about first is identify your independent and dependent. If you go to buy gasoline, because this is our gasoline purchases, so we're going to put gas purchases, do they tell you the price, or do they tell you how much per gallon? Now usually X is our independent, and our independent in this case should be the gallons that you buy. So this is going to be our X. That is our independent, the gallons that you buy. So I'm looking at this, it's just not writing quite right. Yeah. So our X is going to be independent. Since this was a little hard to read, let's see if I can correct that. That's our gallons bought. So when you go stop at the gas station, how many gallons you bought, that's our independent. Y is going to be depending on that. So the Y is the dollars that you spend. I don't like how this information was put in the table. A lot of times independent is first, but in this case, it is not. So we want to choose a good scale. So if we look at our X values, they go from 1 up to 3.3. So again, as we make our scale, we have our title on the type, gas purchase, our purchases, and we are going to put, we just said this is going to be our gallons bought. So we're going to label it down here. And if I'm looking at this graph, I would say that I probably would go like this would be 0.5 gallons bought. This would be 1 gallon. This would be 1.5. This would be my 2 gallons bought. 2.5, 3 gallons, and my largest one was 3.3, so 3.5. How many dollars I spent? I possibly am going to be looking at this, so I want to put my dollars spent as a label. And I might go up by 2s. 2, 4, 6, 8, 10, 12, 14, and really my top one was 13. So I set my scale so that my graph will fit on as I'm looking at that. I am now looking at the ordered pairs. So when I look at the ordered pairs, remember you're going to go 2.5 that you're plotting, comma 10. So if I'm going to go to 2.5, 10. The second one I'm plotting is 2.8. Well, here's 3.0. This would be 2.75, so about in the middle. So 2.8 and 11, which is going to be about right in here. Now, what I'm going to do is I'm going to pause the video. You should plot the rest of the points, and when you've done pausing it, you will see my data points plotted, and if you need to pause it again, you could. You can now see all the points plotted, always thinking in as this was our 1.1, putting the X first, the gallons, and then the 4. So that's where this point was located. And we did that for all of our points, we plotted them. What type of relationship does it show? Well, to me, if I'm looking at this, I would say it is a positive relationship. Why do I say it's positive? Because as the gallons increases, the price increases, which makes sense if you're paying per gallon, okay? So you're going to be asked to think of different correlations. Consider the population of the city and the length of its name of the city. Do you think there's a positive correlation, meaning as the number of letters go up, the population goes up? Negative, as the name of the city, the number of letters goes up, the population goes down, or no correlation between the two? So think about this for just a minute. As you look at this, if we think, okay, let's think of the city of Fargo. Fargo has 5 letters, and let's think about our population. And if you think of the population of Fargo, the city of Fargo, and you think of the city of Castleton, which one has a bigger population? Well, definitely Fargo, but Fargo only had 5 letters. Castleton, when we take a look at it, has 9 letters in the word. This is why there's no correlation, because Fargo has a bigger population than Castleton. The number of letters has nothing to do with the population. So you're going to be asked to give 2 real-world examples of a positive correlation, negative, and no correlation. I am going to give you one. You need to come up with your second one. You kind of want to talk with your shoulder partners as you listen to these, or as you list them, but everyone should have 2 when I check your notes. So if we think about this, positive correlation, in real world. Time in years related to the height that a tree grows from when you plant it. So if you think of when you first plant it, hasn't been in the ground very long, that is going to be a very positive correlation. As time increases, the height increases. How about a negative correlation? You might be thinking about, if we're talking about maybe you play an instrument, so practice time with an instrument, and you practice a lot. So as your practice time on your instrument increases, what happens to the mistakes? They should be going down. At first you might make a lot of mistakes the first time through a new piece of music, and as you keep playing it, your mistakes hopefully are decreasing. So as time goes on, you're making less and less mistakes till you have the piece memorized. Now, you want to come up with your own positive relationship. You want to come up with a negative one. And for no relationship, this is a nice one. We could look at student height and your GPA. There should be no relationship. You want to come up with another thing that's not related. So please make sure if you need to pause this video and then write something down. Everyone should have something. The last part that we're going to be looking at is we want to classify it as linear or nonlinear. Remember, linear is a straight line. Nonlinear could be curved, could be a parabola shaped, positive, negative, and then weak or strong. And you're asked to circle the outliers. Which things are kind of don't fit? Like in this one, here would be our outlier. Here we can definitely see an outlier. So if we are looking at this first one, we would probably say it looks like it could be linear. It is positive because it's going up. And it's kind of a little bit weak, I would say. The points are kind of spread out. This one is definitely, it curves. This would be nonlinear. We would say that it is a negative because it's going down. And if we are looking at is it weak or strong, we would say this is pretty strong if we are looking at that. What about our last two on this page? If we are looking at this one, we would probably say it's linear. It is negative correlation. And if we are looking at it, we would say it's probably pretty strong in that we could draw what's called a line of best fit for this one. I would take for an answer in this last one, I would take either linear, because if I think of this, I think I could draw a straight line like this, or I would also take nonlinear. Why would I take nonlinear? If I was looking at yours and you had it coming something like this, it kind of curves going up, that would be, so I would take either answer for that one. It is definitely positive. It's going up. As x increases, y is increasing. And I would say it's a pretty strong relationship as we look at that. So on your homework, the key thing is as you are doing your homework, it's really important that you set your scales. As I am looking at this one, I would say we are going to look at study time being X and your test scores Y. If I look at this one, I would go with adult tickets and Y. So here, I might have my study time in minutes going along here, but I might put a break in my graph and start here at 70 for my test scores, instead of starting at 0. So I might start at 70 and then pick a scale to go up. As I'm looking at this next one, I'm looking at the distance in feet. That would be my X to my Y being the number of hits. So again, labels telling what's on the sides of each of these. On the back page, you are going to be looking at answering questions 6, 7, and 8. Tell whether the correlation is likely, the kind of correlation, and then explain why you picked that. So you got to kind of give a reason for that. The last page that you're doing, or the last part of it, is to just circle your answer.